Hello everyone, in this video we would like to have a group presentation on our group project SECR1013 Digital Logic, and we are from group 4. So in this group project we are required to design a digital circuit using digital date simulator for lift control system. So here is our group members, and other group members will later present their parts after me. So first of all, I would like to talk about our objectives. So it is to design a 3-bit synchronous counter for the lift system controller, and then implement basic principles of combinational and sequential logic, test and check the functionality of design circuit using this, utilize the components of combinational and sequential circuits, develop problem solving, logical thinking and team working skills, and finally, demonstrate and explain the operation of the lift system. So in this project, our target is to implement a lift system controller of an at-level building using a 3-bit synchronous counter. So this system ensures safety as it requires users to tap the card and enter the 4-bit numerical password to access the lift. To make this system more advanced, we had add on extra features, which is sound notification when reach the target floor and also the lift button. So in this circuit, we have used combinational circuit like basic gates, switches, comparators, and also LEDs. For the sequential circuits, we have used the JK flip-flop and also the clock disabler. For the additional features, which is the 4-bit password, card reader, sound notification, and also the lift button. So here is our problem statement. So in today's world, many security problems have occurred since lifts lack strong security systems. So this will cause people who are not authorized to intentionally use the lift and access other people's floors. Therefore, to help society solve this problem, we decided to create a new lift system using the digital electronic disk simulator. In this system, it only ensures that the authorized owner or approved individuals can use the lift by verifying the card identifier and also the password system. So by the wider implementation of this system in society, cases of unauthorized access could be significantly reduced.
So, to solve this problem, we have come up with a suggested solution that consists of combination of card and a 4-bit password protection. So it integrates a few advanced electronic components such as a 3-bit comparator that compares the current floor and the desired floor, a 4-bit comparator that compares the password stored in the system and the password entered by the user, JK flip-flops that acts as a counters, basic gates to route signals. So have a look at our block diagram. So it consists of an 8 to 3-bit encoder which acts as a lift switch, and this is output to a LED output for the floor choice and the 3-bit comparator. This 3-bit comparator compares the result from the encoder just now, which is the lift switch, and the 3-bit up-down counter result, which is the output from the JK flip-flop. It compares the result for both of them, and it is output to the sound notification and the clock disabler. For this 3-bit up-down counter, it outputs the result to the LED output for current floor. And the clock disabler not only just consists the input from the 3-bit comparator, the input of it comes also from the clock, the power on button, the 4-bit comparator, which comes from the password entered by the user, and the card identifier. So next is our state diagram. So we plan to come up with a 3-bit saturated synchronous up-down counter. So it has an external input which indicates the direction of the counter, which is 0 indicates count up and 1 indicates count down. So as you can see here, when it counts down at 000, which is 1 here, it will saturate, it is saturated and it will loop itself. Same goes to 111 when we need to count up, which is 0, it will loop itself. For others, it is the normal count up or down operation. From choosing 0, count up, and for 1, count down.
I would like to introduce the implementation of our digital design circuit. First of all, this is our main function. We use JK flip-flop we integrate 3 JK flip-flop into the main controller of the leaf system project. These form a synchronous saturated up-down counter. What this means is that when the flow count reaches the higher or lower step, it will remain in the same step. All 3 JK flip-flop are connected to a common clock, which we manage with a clock disable. The main function will stop operation when this clock disable signal is low. Next is the float switch system. We design 8 float switches for user selection. After a user places a switch, the input is encoded into a 3-bit binary value representing the destination flow, which is then displayed. This float switch system supports multiple simultaneous selection. Priority is based on the direction of the leaf. When the leaf is moving outward, the encoder prioritizes the lowest chosen flow above the current position. When the leaf is moving downward, the encoder prioritizes the higher chosen flow below the current position. So that we have the clock disable itself. We implement it using 5 input AND gate. The output of this gate is high only when all 5 inputs are high. These inputs are clock generator, password comparator, flow comparator, card reader, and power switch. This 5 input AND gate design is crucial for determining the start and stop condition for the leaf operation. Next is we have the password comparator. This is a 4-bit MSI comparator chip. Its function is to verify the password entered by user. It will only output a logic high when the enter 4-bit code is actually equal to the preset password, which is 01101.
Next, we have our floor comparator. So for this floor comparator, we utilizes 3 XNOR gates and 1 NAND gates. So the function of this feature is to compare the current flow of the leaf and the desired flow that users enter. So they have two types of output. One is high when the current flow is not equal to the desired flow, and it will output low when the current flow is equal to the desired flow. So next, we have the sound notification. For sound notification, all the inputs are come from the outputs of the 3-bit floor comparator just now. So we had configured a JK flip-flop to act as a D flip-flop by connecting the 3-bit floor comparator to the J terminal and the inverted output of the 3-bit floor comparator to the K terminal. So this JK flip-flop will store the comparator result on 1 clock cycle earlier. And besides, we had connected the 3-bit floor comparator to an inverter, and which is then connected to a 2-input AND gate, which consists of the inverted comparator output and the output of the JK flip-flop. So the operation of the sound notification is as below. When the current flow is not equals to the desired flow, the flow comparator will output a result of high, which is then inverted to an output of low, and contributes to a low to the sound notification. And then at the moment when the current flow reaches the desired flow, the comparator will output low, which is then inverted to high. And since the JK flip-flop stores and outputs the comparator result 1 clock cycle earlier, it will output the high result, the clock cycle before the current flow reaches the desired flow, which is a high, and high contributes a high output to the sound notification and activates the sound notification. At the next clock, the JK flip-flop will only output the low output from the 3-bit floor comparator and contributes to a low output at the sound notification and deactivates the sound. Next, we have the current flow display. So we had utilized three binary bit, 1 bit binary output and a hexadecimal output. So this is just shows the current flow of the leaf, and it can shows in both binary and hexadecimal form. So this is driven by the JK output of the JK flip-flops counters, so that it can show the current flow of the leaf. So have a look at our full digital electronic bit circuit.
In conclusion, this project has successfully demonstrated the design and implementation of an elevator by using combinational system and sequential circuit digital logic. The system was designed by implementing a 3-bit synchronous counter and other components such as JK flip-flops, disable clock, comparator, encoder, and others. So this collaboration of components enable the function of the system to work. Okay, let's move on to reflection. Uh, this project enhances our understanding of digital logic and provided us valuable practical experience in the application of digital electronic concepts in real-world scenarios. And in the future, we are excited to implement more complex circuit with more exciting options. And we're looking forward to applying our knowledge in related field and applying it to real life situation. That's all. Thank you.